So our next topic is going to be Introduction to Polynomials. And the goal here is going to be to evaluate and then also be able to add and subtract polynomials by the end. So first thing is, what is a polynomial? So a polynomial is going to be made up of different terms. So each individual part is going to be a term. And then all of these pieces are going to be added and subtracted from each other. Each term is going to be of the form some number times x to a power. And when we say this power, so m can be numbers 0, 1, 2, and going on forever. So we're looking at things of the form 2x squared, or something like 3x, or something like 5x cubed. Those sort of things being added together. Something like 6. I know that doesn't have an x attached to it, but it really does. It's really x to the 0. What we're not talking about is we're not talking about things like the square root of x or something like 1 over x. We're not talking about that. So we're talking about a number times x to a power. Those powers are the numbers 0, 1, 2, and goes on forever. So a monomial, it has one term. So something like 2x squared, which we've listed. Everything I listed before, those are all monomials. Binomials are going to have two terms. So something like 3x minus 1, maybe 5x squared minus 2, 6x cubed plus 4x. Those are all binomials. A trinomial is going to have three terms. So something like 3x squared minus 4x plus 1, or something like x squared minus 2x minus 8. Those are trinomials. And then polynomials can have as many terms as you want. Everything I've listed is a polynomial. They're just special cases of polynomials. First thing we want to be able to do is evaluate 2x squared minus 4x plus 6 whenever x equals minus 4. So when we write 2x squared minus 4x plus 6, this is actually instructions on what to do with x. X is just a placeholder. So you could actually replace it with anything that you want. I like to use hearts and stars. So you could do 2 times the heart squared minus 4 times the heart plus 6. This heart is just your placeholder. So if we're trying to evaluate this when x is equal to negative 4, or when the heart is equal to negative 4, everywhere I see that placeholder, I'm going to replace it with negative 4. So it'll be 2 times negative 4 squared minus 4 times negative 4, and then plus 6. Negative 4 squared is a positive 16, so 2 times 16. And then negative 4 times negative 4 is a positive 16, and then plus 6. 2 times 16 is 32, and then 16 plus 6 is 22, so it looks like we get 54 once we evaluate this. The next thing we want to be able to do is combine like terms. So when we say like terms, I'm talking about the different powers of x. So things like an x cubed, an x squared, an x, and then your constant term, 1, or something multiplied by 1. The analogy I like to use here is you could think of this as kind of like grapefruits for your x cubed, maybe like oranges for your x squared, maybe like tangerines for your x's, and then maybe like the little mandarin oranges. So your mandarin oranges are your constant. So yeah, they're all related, they're all citrus, but you can't really put them together, right? Like you can't put grapefruit and oranges together because they're not the same. They're part of a family, but they are different. So when you go to combine like terms, you can't put different powers of x together. That's just not going to be allowed. But what we can do is we can combine the ones that have the same power. So what I'm going to do is in this problem, you can see we have x cubed and then down to constants. So I'm going to kind of make some columns here. So I'll have an x cubed column, an x squared column, just an x, and my constant. And since we're going to be adding these together, I'm going to kind of match everything up. So I'm adding up 5x squared, and I'm adding up a minus 2x and a 7. I want to add to that 3x cubed minus 9x squared and minus 11. And the reason I wrote this vertically is because now I can just combine everything in each column. So I'll have 3x cubed looks like minus 4x squared because 5 minus 9 is negative 4, minus 2x, and then minus 4. So once I simplify it, that's my answer. And let's try this again. So again, the highest power term is x cubed, so I'll have x cubed, x squared, x and my constant. This time we're subtracting, but it's the same thing. So I'll go through. First thing I have is 4x cubed minus 2x plus 8. And now I'm subtracting off everything in the next set of parentheses, so let's not forget to distribute. So I'm subtracting off 3x cubed, but then that negative 9 becomes a positive 9x squared, and then plus 11, which gives me x cubed plus 9x squared minus 2x plus 19. Let's do a little bit harder one. This time I only have x squared, x terms, and my constant term, but we do have 3 pieces, so let's just go through this. So in my first piece I have 2x squared minus 4x plus 3. So I'll put all that in the appropriate columns. For my next one I'm adding, so I'll add 5x squared minus 6x plus 1. I don't need to change the sign of any of that. And then in my last one I'm subtracting, so let's not forget to distribute this negative to everything. So minus x squared plus 9x minus 8. Which should give me, let's see, 2 plus 5 is 7, minus 1 is 6. Then I'll have negative 4 minus 6 is 10, negative 10. Plus 9 gives me a negative 1. And then 3 plus 1 is 4, minus 8 is negative 4.